A quiet kitchen, pot rests on a sleek glass stove. No flame, no glow. A single touch, a soft beep. Moments later, steam begins to rise. The water inside the pot boils rapidly, but the stove remains cool. It seems like magic, but behind it lies a powerful scientific principle. This is the world of induction heating: fast, efficient, and invisible. To understand it, begin with the basics: electric current and magnetism. When electricity flows through a straight wire, it creates a magnetic field around it. The more current that flows, the stronger the magnetic field becomes. Reverse the direction of the current, and the magnetic field flips too. Now imagine the wire is wound into a coil. In a coil, the magnetic field is concentrated and much stronger. Introduce alternating current, or AC, which changes direction rapidly. This creates a pulsating magnetic field, constantly switching directions. This effect is at the heart of induction heating technology. But to make it really powerful, a special circuit is used called an oscillator. The oscillator creates high-frequency AC, tens of thousands of cycles per second. Frequencies around 50,000 Hz are typical. That means 50,000 direction changes per second. This rapidly changing current flows through the induction coil. Around the coil, an invisible but intense magnetic field forms. Place a metal object, like a cooking pot, on top of this coil. The changing magnetic field interacts with the metal. And here's where the real magic begins: electromagnetic induction. Inside the metal, swirling electric currents are generated. These are called eddy currents, and they flow in tight loops within the material. As they move, the natural resistance of the metal turns this motion into heat. This heat is not from the coil, it's generated inside the metal itself. No open flame, no heating element, just the material heating from within. That's why induction is incredibly fast and efficient. Almost no energy is lost. Most of it goes straight into the cookware. But not all materials work with induction. To respond to the magnetic field, the cookware must allow eddy currents to form. Materials like glass or aluminum don't work well. They lack the right properties. Induction heating works best with ferromagnetic metals like steel or cast iron. These materials are both magnetic and moderately resistive, perfect for generating heat. That's why many cookware products are labeled induction compatible. It's a combination of science and smart material selection. But induction heating isn't just for cooking. In factories, it's used to melt, forge, and harden metal parts. Large coils surround engine parts, tools, and other components. With precision timing, they heat specific sections without touching them. The result is cleaner, safer, and faster industrial processing. Even the medical field uses induction, like in devices for surgical sterilization. All of this powered by invisible fields and flowing currents. Back in the kitchen, the technology works silently. The pot boils, the stove stays cool, the energy flows efficiently. It's science hidden in plain sight, a fusion of electromagnetism, engineering, and everyday life. From home kitchens to high-tech labs, the power of induction is quietly transforming the world. Now, the next time a pot boils without fire, the secret behind it is no longer a mystery. Thanks for watching. If you love tech and science made simple, hit like and subscribe for more.